Hi there. Question number 8. It is given that v is equal to y to the 4 and y cube times dy d2y over dx squared plus 3y squared dy by dx to the square plus y cubed dy by dx plus y to the 4 is equal to e to the minus 2x. Part A show that d2v over dx squared plus dv over dx plus 4v is equal to 4 into e to the minus 2x. Now the way we do this question is very easy. So what we should basically do now is we're going to try and differentiate this here v in terms of x. So dv over dx is equal to ddx y to the 4, and then so this is going to become 4y to the cube dy by dx, and then once we get this, we're going to try and differentiate it a second time to get the second derivative, which is d2v over dx squared. And of course we're going to be using the chain rule and product rule simultaneously to be able to find the second derivative. Once we get the second derivative, and we also know that v is equal to y to the 4, we're going to replace all of those expressions into the original differential equations over here, and this should be able to reduce to d2v over dx squared plus dv over dx plus 4v is equal to 4e to the minus 2x. So 4 marks for that question. Second part of the question here, we need to find y in terms of x, given that x is equal to 0, y is equal to 1, and dy by dx is equal to minus 3 over 8. So what we're going to go and do is we're going to try and solve this reduced differential equation here, d2v over dx squared plus dv over dx plus 4b is equal to 4e to the minus 2x. Now this here can be equated to this, the left hand side here can be equated to 0, and the auxiliary equations can be found to be m squared plus m plus 4 is equal to 0. Once we solve this, we should be able to get some complex roots, and for complex roots the complementary function is going to be of the form e to the alpha x into a cos of beta plus b sine of beta, and alpha and beta can be found in the complex root. The real part is basically alpha, and beta is going to be the complex part of the root. So once you substitute those roots into the equation, you should be able to get your complementary function. And for the particular integral, we can look at the right hand side over here and try y is equal to, let's say, ke to the minus 2x, and then we can differentiate it twice and substitute those two derivatives, the first one and second one, into that differential equation, and it should be able to give you the value of k, which would then be probably 2 or 3 or something like that. Kind of worked it before but can't remember. So once you got that, then you're going to have to substitute the initial values of the differential equations, and they were actually given here. X equal to 0, y is equal to 1, dy by dx equal to minus 3 over 8. So you take that, you substitute it into your general solution. The general solution is made of the complementary function plus the particular integral. And if you were to do this, you will substitute those values in there, and you should be able to solve for a. And then once you do that, also you can substitute those original values into the got dy by dx here. Yeah, so can you see here? Yeah, then you should be able to solve for cos, for a and b, and once you do that, just put in your values that you've already just found into the equation, and you should be able to get the general solution with all the constants found, which should then give you 10 marks. Take